I would like to introduce today's moderator. So thank you, Dr. Minsinger, for joining us today and for helping to put all of this together. Dr. Minsinger is a retired orthopedic surgeon who was just honored for his more than 40 years as the president of the Blue Hill Observatory. The highest wind gust in the 1938 hurricane, 186 miles per hour, was recorded at the observatory. In 1988, Dr. Minsinger compiled a book for the 50th anniversary of the storm, the 1938 hurricane, an historical and pictorial summary, which has gone on to 16 short-run printings. He continues to be fascinated by this storm, always learning new details as time passes, and looks forward to share details of this remarkable storm. And with that being said, Dr. Minsinger, I give the floor to you. Thank you.
Great. Well, thank you, Gideon. And thanks for everyone for signing on. And again, sort of people wonder why perhaps we're still talking about the 1938 hurricane. And I think that you'll see from Dr. Uccellini and Dr. Avilés' talks, there are things still that can be learned. So I'm very pleased to have had Dr. Louis Uccellini, who's the retired director of the National Weather Service, join us. He is now a research professor at the University of Maryland at College Park. And Dr. Lourdes Avilés, she is the assistant provost at Plymouth State University, but had been a professor there in the Department of Meteorology as well. So both of them are very well qualified to talk about this storm. So Gideon, can we bring up the first slide? So again, why do we study this? So the storm, the 1938 hurricane, also known as the Yankee Clipper or the Long Island Express, really was a significant storm, certainly in New England's history, and a significant storm perhaps in any location. So the storm produced damage would amount to $45 billion in today's dollars. There were 685 plus lives lost, and there was wind, storm surge, flood, and fire. The storm sort of produced all sorts of damage in New England. So again, we'll cover all aspects of that. And the unique aspect of this storm is it was not well forecast. And one of the reasons it wasn't well forecast was because of its very rapid forward speed. So it was approaching the south shore of Long Island somewhere around 60 miles per hour on September 21st, 1938. And obviously produced high winds. So again, you can see 120 miles per hour on the top of the Empire State Building at elevation, 186 miles per hour, give or take a few miles per hour at Blue Hill Observatory. There was only one anemometer that survived at Blue Hill Observatory, and 162 miles per hour on top of Mount Washington. So those winds were aloft, not at ground. But certainly there was plenty of wind and plenty of wind damage that will show. And then along with that, with the rapid progress and the strong southerly winds, this storm came ashore on sort of the western end of Long Island. So there were strong southerly winds along the Rhode Island, Connecticut shore into Cape Cod Bay, and they produced a significant storm surge in all those locations, and then sort of a slosh event in Long Island Sound where the tides went way out and then came back as a flood tide. And then the most interesting thing here was that there already was flooding occurring before the hurricane arrived, because there had been a trough on the East Coast for several days, leading to very heavy rainfall, especially in the Connecticut Valley and somewhat west of there, so that the rainfall then from the hurricane only exacerbated what already were flooding conditions. And interestingly enough, there were fires in New London, Connecticut, and Peterborough, New Hampshire, which really weren't put out by the fire department. Both of those fires were very difficult to fight in the midst of a hurricane. So the other thing that we'll certainly talk about, and the reason that we should always think about the 1938 hurricane, was the lack of adequate warning. And Lou and Lourdes will speak of this. The forecasting issues and how the Weather Bureau actually changed, and then perhaps some recent advances that helps us with storms such as Sandy, which was a great forecast or Dorian, which was again a recent great forecast, etc. Next slide. So here was the downtown Providence, Rhode Island. And when we talk about the 1938 hurricane, we always need to sort of say that there were three great New England hurricanes, 1635, 1815, and 1938. And each of those storms produced significant flooding in Providence. Providence, Rhode Island sits at the apex of Narragansett Bay, and with a strong southerly wind that occurred in all of these storms, storm surges driven up into the three rivers that meet sort of at Providence. And you can see that in the left-hand picture, that was 1938. City Hall is on the left. The Biltmore Hotel, which is still there, is in the middle of the picture. And the water was about 13 feet deep here. So at the very bottom, I think, of the screen, if it projects well, you'll see a streetcar. And streetcars were fairly tall. They were over your head. And the water was up to the windows in the streetcar. So that, again, people were actually drowned in downtown Providence. And one of the problems was that people were leaving work 4:45, 5 o'clock, just as the storm surge was approaching. And they stepped into the streets and there was some water in the gutters. But within 15 or 20 minutes, this is what the scene was like. So that they were actually throwing sheets out tied together to try to catch people as they swirled around the Biltmore Hotel. And there were people that lost their lives right here, sort of at City Plaza in downtown Providence. Now, on the right, you see the picture of the same location just about in 1815. So it was September 15th, 1815, a similar storm caused flooding. Now, at the old market building in Providence, they were so impressed in 1815 that they put a brass plaque on the market building, and it said in 1815 the water rose to 11 feet 9¼ inches. They didn't think that they'd probably ever see that again. But in 1938, the water rose to 13 feet 8½ inches at that location, and a new brass plaque is on the building above the old brass plaque, again to commemorate the significant storm surge that occurred. Now, there is a floodgates here that hopefully might protect Providence from such significant flooding in some future storm. Next slide, Gideon. So here was the height of the storm, Washington Park Yacht Club, and within 10 or 15 minutes after this picture was taken, this building was swept off its pilings and was destroyed. So again, this is the type of thing that here was someone at the yacht club. They realized it was quite a significant storm, got their camera out to take a picture, but they really were not anticipating a hurricane. The forecast for that day was a northeast wind, a northeaster, if you would, or a line storm. Line storm referring to the equinox, and this was the equinox. And oftentimes there would be bad northeast storms, perhaps remnants of hurricanes in New England. So they would call them line storms. But this was actually a true hurricane that passed to the west with a strong southerly wind. And that's where the forecast had been incorrect. Now, the last really significant hurricane in New England was the Saxby gale that went up into Fundy Bay and caused a tremendous storm surge in that area. But that was in 1869. So there really wasn't anyone alive that had witnessed a hurricane, at least of this proportion, in New England. Next slide. So again, there are foci of significant damage, and this was one of those. So this was Napa Tree Point to the west of Watch Hill, Rhode Island. So what you see is the overwash of what had been a barrier beach. So to the right is the Atlantic Ocean. To the left is Little Narragansett Bay. And you can see that the ocean came and swept everything into Little Narragansett Bay. There was a road there, Fort Road, that went out to Fort Mansfield, a Civil War era fort. And Watch Hill is at the very top of that picture. And you can see the substantial cottages that were along that with a seawall in front of it. But none of those cottages survived. There were 42 buildings that were swept away there. And there were essentially just 2 telephone poles left from the storm surge here. And they've never allowed them to rebuild along this area. Now, the people that were in these cottages were all swept into Little Narragansett Bay. And I always talk right in the middle of this photograph is the Helen Joy Lee House. Her grandfather had built this. He had been the president of the Packard Car Company. Packard cars were like Cadillacs in that time period. And he built a substantial cottage. She realized that at about 3:30 in the afternoon, that water was lapping at her door, coming over the seawall. So she got her Eldridge tide table out and realized that high tide wasn't for another 2 hours and realized she was in trouble. So shortly thereafter, the house began to break up, and she actually got outside, got onto a porch roof of an adjoining house that had turned over, was in the water, and she rode across from Fort Road, Rhode Island, into Connecticut. She was actually driven right across in the Little Narragansett Bay into the state of Connecticut. I always called her the first interstate traveler. Next slide, Gideon. So here's Blue Hill. So we're at an elevation 635 feet, just 8-10 miles outside of Boston. And again, to the right is the anemometer that survived, and to the left is the barometric pressure. So we got down to just about 29 inches. And again, the anemometer that survived actually created a slope. And through that slope, they magnified that multiple times and finally came up with, they thought it was a wind gust to 186 miles per hour. But there is some plus and minus to that. But the interesting thing is that just about at 5 o'clock at night, the wind was strong out of the south, up the steep side of Blue Hill, and sustained winds for 5 minutes were 121 miles per hour. So again, there weren't a lot of tall trees at Blue Hill, on the top of Blue Hill at that time, but there was certainly significant wind that day. And probably down below, the estimates were gusts to 85 to 90 miles an hour that took down a lot of trees. Next slide, Gideon. So this is a representation of the wind damage in New England. You can see that it occurred in all 6 states. This was marketable timber. So what you see here in red probably was really white pine. And the U.S. Forest Service actually had a whole section devoted to salvaging these logs because there were so many white pine that were damaged. Now, further down at Connecticut and Rhode Island, you see that there isn't as much red. That doesn't mean that there weren't trees down there. There were thousands of trees down in Connecticut and Rhode Island as well, but they were mostly elm trees and they weren't as valuable. So they did not buy those trees for lumber. But you can see that the damage went all the way to the Canadian border here. This actually is the reanalysis track. And I was saying to Lewis and Lourdes that I thought that this was a little too far west, but that's what now they feel the track might have represented. But clearly you can see that with the southerly wind, there was damage all the way to every state in New England. Next slide. So again, I had talked about the trough on the East Coast, and that's one of the reasons why this storm came up into New England. But this trough had already produced heavy rainfall for 2 days before the storm. So there were areas that were already in flood before the hurricane arrived. And you see, again, Ware, Massachusetts. This was Main Street in Ware, Massachusetts, with tremendous flooding ripping down the street. And actually after this, the pavement had been eroded so badly that the only thing that you saw, you didn't see a road, the only thing you saw was the sewer pipes. And again, you can see that the maximum rainfall was 12.77 inches in Gardner. That included the pre-hurricane rains and the hurricane rain. Next slide. So this is similar town, Ware, New Hampshire, a little different spelling, but here was before the hurricane arrived. This is what it looked like in Ware before the hurricane rains. Next slide. So this is, again, Peterborough, New Hampshire. And it was interesting. I've studied this storm for years and went down and listened to the executive director of their historical society. And the slide that you see on the left-hand side, that was early morning, September 21st, 1938. The hurricane didn't arrive until 5 o'clock, 6 o'clock at night there. So here was the flooding in the morning of September 21st, all from this pre-hurricane rainfall. Now, they suffered wind damage as well. You can see what it looked like on the next morning, September 22nd, elm trees down throughout the town. Next slide, Gideon. But this is what occurred in Peterborough. So we don't know exactly how the fire got started. The executive director said that they already lost electricity by the time the fire started. It was always said that it was an electrical fire, but there are 5 or 6 buildings that were lost by fire. And really, probably what happened was the wind shifted finally as the hurricane passed them to the west and put out the fire. The firefighters really couldn't put out the fire because they couldn't get to the buildings because of the flooding. And when they tried to throw streams of water on it, the wind was so strong that the streams were just blown away. So you can see the utter destruction in Peterborough. Some of these buildings that you see in the picture are still there. If you go to Peterborough today, you can just sort of imagine what it must have been like on September 22nd, 1938. Next slide, Gideon. So here, same type of situation, New London, Connecticut. So if you see on the left side, this white boat is the Marcella. The Marcella has a broken bowsprit there. That was a sailing ship. But the boat had gotten loose from its moorings, and the bowsprit was broken off in a dockside factory. That caused a short circuit, and 8 blocks of buildings were destroyed by fire in New London. And again, the interesting aspect of things here, and Lewis will actually show a little bit of video of this, or an aerial shot. The firefighters got there, laid their hoses down, tried to shoot water onto the fire, and the wind was blowing so strong out of the south that the stream of water was actually blown past them over their heads, backwards. Then, within about 20 minutes, the storm surge began to come in New London, Connecticut. So they finally had to sort of cut their hoses and get their equipment out as they were in seawater up to their necks trying to put this fire out. So, I mean, I always tell emergency management folks, I said, you tell me that you have a plan for that scenario where you arrive at the fire and suddenly the storm surge is coming up and you have to pull your equipment out because everything is being flooded by the sea. So it was a wild night in New London, Connecticut, and the local paper reported that it was the largest fire since Benedict Arnold had burned the city in the War of 1812. Next slide. So again, we talked about winds, 162 miles an hour on Mount Washington. And this, for many of you perhaps have ridden the Cog Railway, Jacob's Ladder, that was actually blown down by the wind. So the original trestle was 30 feet, has been rebuilt to 20 feet. But this was not an insubstantial structure and has survived many a high wind on Mount Washington, but didn't survive the 1938 hurricane. Next slide. So again, here are Charlie Pierce. Charlie and Lourdes will go into this extensively here. He wrote the meteorological history of the hurricane September 21st, 1938, and discussed the extratropical transformation of the storm. So again, these are his classic maps, and he actually had the storm going a little bit further east than the reanalysis, sort of more or less in the line that goes up through central Vermont there. But again, he was fascinated by this storm, and we were fortunate enough to have him talk on the 50th anniversary of the storm at Blue Hill Observatory. Next slide. So here's a little comparison. Again, we'll talk maybe a little bit about Sandy, but this is really sort of an interesting comparison. Very similar type situation. Again, 27.95 at the landfall of Bellport Coast Guard Station on Long Island, 27.92 Atlantic City from Sandy. Almost the identical rainfall, but Sandy was well forecast. Most of those deaths occurred in the Caribbean, and the 1938 hurricane was not well forecast, and you can see, again, the number of deaths. So Dr. Uccellini will sort of talk about some of the advances, some of the changes that were made in the Weather Service, and some of the advances that have been made that have produced better forecasting for hurricanes. So I'm going to turn this over to Lourdes, and she'll talk a little bit about Charlie Pierce.
All right. Good evening, everybody. I see the slides have gone away, so we'll wait for them to come back. But I would like to thank Gideon for getting us all set up, and Dr. Minsinger for getting us organized and inviting me to be part of this. So my part of this presentation will be to talk about the forecasting and the forecasters. So I'll give you a little introduction. As Dr. Minsinger said, I am the Associate Provost at Plymouth State University. And for almost 20 years, I was a professor of meteorology. And I have been fascinated by this storm for a long time. If you want to go to the next slide, please. I can tell you my story with the storm. I grew up in Puerto Rico, so hurricanes, or at least the threat of hurricanes, were part of me growing up and me being fascinated by hurricanes, and eventually deciding to go into atmospheric science. And, did my dissertation in the formation of hurricanes, Atlantic hurricanes. So when I took the job here at Plymouth State, coming to New England, I naively thought that I was done with hurricanes. I was always focused on Caribbean hurricanes. And, at most, I thought about Florida and the Gulf of Mexico. But a student project in a course I taught during my first semester, a tropical meteorology course, made me aware of this storm, and I started looking into it. And the more I looked, the more I found. I gave a very well-received seminar where somebody suggested I write a book, and I was like, oh. So I eventually did write this book, and I spent a lot of time looking at hundreds and hundreds of documents and reports and letters and pictures. And I still come across them. People still send them to me. I like to say that I could talk about the storm for 10 hours. So keeping it to 20 minutes is a bit of a challenge. So my take was that I wanted to do an interdisciplinary study of the storm. So not just the meteorological history of the storm, but all the other sciences, the forest ecology, the geology, anything I could find out about the effects of the storm, and also use it as an opportunity to learn about the history of hurricane forecasting, observing. So the result was a book published by the American Meteorological Society for the 75th anniversary of the storm, which was 10 years ago. And because of this book and because of my research, I have had the opportunity to do many talks, many presentations and interviews. It's been a lot, and it's been crazy and fun. And if I counted correctly, this is my 54th presentation about this hurricane. So it is my honor to be here with these distinguished guests, co-presenters. So the next one, please. So I will mostly focus on the challenges of forecasting the storm, how hurricane forecasting was done in the 1930s, and what happened and what didn't happen. And I will highlight, as Dr. Minsinger mentioned, the role of Charlie Pierce, what he did. So that was a very fascinating aspect for me to dig into when I was researching the book. Next, please. So the hurricane was Cape Verde hurricane. It formed very quickly after a tropical wave came out of Africa. It moved westward across the Atlantic as it intensified, and then it recurved and came into New England. While I was finishing the book, the reanalysis project had just reanalyzed the 1938 hurricane. And as many of you, I'm sure, knows, the hurricane database is the official track for all Atlantic hurricanes, the so-called best track. So I was able to get my hands on the reanalysis before it was published. So I highlighted the track of the storm, but what we need to keep in mind is that the ways in which we detect a hurricane today were not available to forecasters back in 1938. of course, no satellites. Those started in the 1960s, and we didn't have full coverage of the globe until 1979. Radar, as the storms approach, that was used for meteorological purposes for the first time in the late 1940s and 1950s. Hurricane aircraft reconnaissance was done for the first time in the 1940s. So none of these tools that we use these days to gather more information, much less to know where a storm is, were available. And most of the information back then came from ships at sea. And this blurry, dark picture I have there is a steamship, the SS Alegrete, which was a Brazilian cargo ship, which is the first one that encountered the storm. And so they saw northeast winds turning east, then turning east-southeast. And from that, I was able to draw that diagram there that shows that the ship likely was moving through the north side of the eye wall. So these ships, there's a surprising amount of information that you can learn from this information, from just pressure and wind measurements, wind direction. You can figure out where the storm is, especially if you have more than one observation. You can do triangulation. You can know the strength of the storm from the pressure. There's this pressure-wind relationships that have been used for a very long time and have been honed over the years. And that's part of what the reanalysis project does, is to work with those. So we did not know that there was a storm formed right off the coast of Africa. We only, for the first time, learned about it when it was on the western side of the Atlantic Ocean, kind of nearing the eastern side of the Caribbean. So the problem with ship observations is these were ships that encountered the hurricanes because they were on the wrong place at the wrong time. So you might imagine that then they start calling each other, telling that there's a hurricane. So obviously they're going to leave and be somewhere else. So the more information there is about the position of a hurricane, the less information you got later because ships stayed out of the way. So next, please. So as you know, these days, the National Hurricane Center is in charge of forecasting, monitoring, putting out hurricane advisories, etc. Back in 1938, there was no National Hurricane Center, which formed in 1955, right after a terrible hurricane season that affected the East Coast in 1954. In 1938, we had what was called the Hurricane Warning Service, and there were 4 forecast offices, one in San Juan, one in New Orleans, Jacksonville, and Washington, D.C. And depending where the hurricane was the office in charge of monitoring, forecasting, doing warnings. So when the hurricane was first observed, when the Weather Bureau first heard about it, it was in the Jacksonville, Florida forecast region. So they were the ones to first get information from the ships, trying to figure out where it was going, how strong it was. And then as the storm recurved northward, it fell in the Washington, D.C. office's jurisdiction. At first, it looked like it was going to go straight into Florida, and this was just 3 years after one of the strongest hurricanes to have made landfall, the Labor Day hurricane of 1935. So they took it very seriously. Red Cross went down there. But then they realized from the observations that the storm was likely recurving. Next, please. So the Washington, D.C. Bureau, first of all, the National Weather Service was not named so back in 1938. It was called the Weather Bureau. And it was organized such that there was a headquarters office in Washington, D.C., And NOAA didn't exist just yet. And they called that one the central office. And then they had what they call field offices, where Jacksonville, San Juan, and New Orleans would be three of those field offices. There was one forecaster in charge, and he was the boss. So everybody that worked there was at his service. These forecasters in charge had month-long shifts. So they were on call 7 days a week, 24 hours a day for a full month. And then they would take 1 month off. Of course, I imagine they slept and ate, but they were on call to deal with whatever happened. They had a team of 16 forecasters, I guess. They called it the map and radio force. And these were people that were gathering data that was coming in any form, shape, that they could get their information via telephone, via radio and telegraph. And they were hand drawing the maps. And the picture on the top right is from a few years earlier, but this is how the Washington, D.C. office, this is a picture from the actual office, looked. You can see is architect tables and gentlemen, old men, doing the map analysis in their suits. So a little different than now. The central office, the DC office, also had what was called the Professional and Technical Services. And part of that was Meteorological Research Division, and that had an air mass analysis group. So this was a research group to learn and understand better how what they called air mass analysis worked. And this was based on the European Norwegian frontal analysis that had been developed in the previous couple of decades. So back in the 1930s, there was Roosevelt called a science advisory committee to see how well the Weather Bureau was doing in forecasting, and they suggested that we needed to put in the state-of-the-art knowledge about the atmosphere. They also suggested we needed more observations and other things like that. So they the field offices would send their forecasters to the central office to get trained, but they also had their own forecasters that they had hired into this group. And that picture at the bottom right that I did not mention, that was the actual building where the Weather Bureau central office was, this castle-looking building. You can see the weather station on the roof. It didn't really follow the WMO guidelines for weather stations. So that, as far as I can tell, that building does not stand anymore. So can we go to the next, please? So this gentleman here, Charles H. Pierce, had just been hired the previous year. He appeared for the first time in the roster of the Weather Bureau in 1937, and he was hired to the Air Mass group. There were 8 meteorologists in that group. And I was just reviewing, I reread the chapter of the book where I put all this information, and it reminded me that his salary was $2,600 per year. So that would be about $56,000 right now. Not bad. So one interesting thing about Mr. Pierce is that he had a college degree, which was not normal back in the 30s. In fact, they were trying to get that going where they were trying to get the meteorologists to be educated at the university. But before that, most Weather Bureau meteorologists were trained on the job. So experience was extremely important. So Pierce was a rookie at the Weather Bureau, but he was not a rookie meteorologist. He had a degree. He had been working for many years in the aviation industry, specifically for TWA. And what that gave him was the insight that upper air observations were important. And he would have, without thinking, looked at any upper air observations that were available. So the people in the air mass group did not do forecasting. They were not part of the map analysis or forecasting. But the report is that they did a daily weather briefing, of which Pierce would have been part of. There's no record that he was in charge of presenting that day or not. The story is that somebody was out and he was asked to fill in that day for the weather analysis, the map analysis group. So he had a front seat on getting the observations. And the story goes that he figured out the storm was coming, and he told his superiors and nobody listened to him. So what I did is I tried to figure out as much as I could how much of this story could be true or could not be true. And in part with help from Dr. Minsinger, who talked to him directly, and in part by reading reports from the then chief of the Weather Bureau, Chief Greg. His first name is escaping me at the moment. I learned that young meteorologists were encouraged to put practice forecasts together that then later in the week they would discuss with the senior forecasters. So it is very likely that he, on paper, put together a forecast saying this storm is coming up. There's no way he could have known that it was moving as fast as it was moving, so it would not have been as urgent. It is possible it was discussed in the day's briefing, but that would have been too late because the forecast had to go out in the morning so that they could make it to the midday newspapers. So normally the lead forecaster, maybe he would be part of these discussions or not, but normally he would not be using these discussions to prepare his forecast. He, maybe for an evening forecast update, if he deemed them useful. But they were more for educational purposes of the visiting forecasters and the group that was doing research. Next, please. So as the storm came into the Washington, D.C. Jurisdiction, there was a shift in the way in which the advisories were being made. When it was in the hands of Washington, Jacksonville, they had a lot of information about the position, the direction. They had advice to be ready for potential warnings later. But as soon as it went into the D.C. region, it was more a listing of what warnings were posted along the coast. So a lot less descriptive, no more word hurricane. And most of the warnings that were put, there were gale warnings and things like that. But northeast storm warnings was the one that was the most used. And those types of warnings do not exist anymore. The flag symbols are there, that the square that we use now for tropical storm, and then a triangle, a red triangle, that was a northeast storm warning. They would have used this when there was a nor'easter, for example. So they would have been familiar to people in the northeast, but not as alarming as a hurricane. So the meteorologist in charge, his name was also Charles Mitchell, was one of the most experienced in the nation. And I have a little a little more on him later. But if you hear the stories, you would think that there was this showdown between the two of them. These two pictures are about 50 years after the events when both gentlemen were retired. But it would be the new ways with the air mass analysis and Opera observations. The old ways were experience and intuition, and the two of them arguing. But I don't think any of that happened. There is no proof. And people would have been very respectful of the position of Mitchell. And as I figured out, it is possible it was discussed among them and in the midday briefing, but this was a forecast that was put in an envelope for later review, and also likely not thought of as urgent. Next, please. So Mitchell was definitely one of the most revered forecasters in the nation. In fact, the AMS award for services, longtime services as a forecaster, is named the Charles Mitchell Award. And an interesting thing is that in 1924, he had done a really, really extensive analysis of hurricanes in the Atlantic and their tracks. And one of the conclusions that he made was that if there was a strong high pressure over the ocean, the hurricane would not be able to recurve. So he himself had described what happened with this hurricane in his study. So it's a little perplexing to think of why he didn't recognize this. However, they really didn't have a lot of data off to the ocean, and from everything I figured out, there was just one piece of information, which was in the DC area, actually, winds determined to be aloft from the south, just from observing the high clouds moving. So I don't think we could blame him for not recognizing what he himself had determined in his study. The little excerpt there is from, I meant to tell you earlier about the daily weather maps that the Weather Bureau and then the Weather Service that NOAA have put together since 1871. So in one of the corners of these maps, there's a summary of the previous, at least at the time of this hurricane, is a summary of the previous day's weather. And this one is signed C.L. Mitchell, which is our lead forecaster. And he very, very, very purposefully did not use the word hurricane in this blurb. It says that the storm of tropical origin. He did not. And the thinking is that he was not going to use the word hurricane, and you did not tell him what to do or what to say. Next, please. So another thing that is reported about this supposed encounter that likely did not happen, but it is probably accurate in terms of what people believed back then, is that hurricanes avoid New England. The New England population was certainly not used to hurricanes. We cannot blame them for thinking this, because a lot of the hurricanes would recurve into the North Atlantic. And as they were doing that, they encountered much colder water and they normally would weaken. So normally they would either miss New England, or if they came, it was weaker remnants that the effects were more those as a summer nor'easter with lots of rain, but not much to think about. Another interesting thing is that if you were one of the most experienced forecasters with the Weather Bureau, let's say you worked for 70 years for the Weather Bureau, you would have never, ever seen a major hurricane make landfall in New England. So as Dr. Minsinger mentioned, 1869 was the last significant hurricane. And in fact, there were a couple significant landfall as a major hurricane in the area, and the agency that later became the Weather Bureau, that later became the Weather Service, was established in 1870. Of course, once this storm happened, everybody went back to figure out all of the big hurricanes that had affected the region. I came across several reports from different agencies where, after the fact, said New England hurricanes can happen, and here's some examples, but it was all after the fact. Nobody was thinking of major hurricanes when they happened, and they cannot be blamed for that. Next, please. So this is how they expected. Hurricane Bill in 2009 is a good example of what they expected the hurricane would do, kind of recurve into the North Atlantic, maybe affect the Nova Scotia area. So the newspaper clip is from the New York Times, which reported on the storm and reported how Floridians were relieved and how only transatlantic ship routes needed to worry about it. Now, the next day also they mentioned it again. I didn't put it here, but I always find it a little shocking that because the New York Times was a local newspaper to Long Island, especially in southern New England, many of the people that lost their lives in the storm surge on that day, it's possible they read on the newspaper how this storm had moved out of the way. So next, please. So the forecast on the day was for a lot of rain and then clearing later in every single area in New England. And it was very reminiscent of what we would call the passage of a front, what we call now. But back then, the terminology was not well established. The studies that led to it had already happened, but people use many different terms, and the symbols also were not well established. So on the top right is one of those daily weather maps, the one for September 21st, 1938, and there's the hurricane on the right, and there's the bottom, there's the blurb from the previous day, and at the bottom left is this forecast that I'm highlighting here. Next, please. So what was happening was that there was a very deep upper level trough. This analysis was put together during the year after the hurricane by Pierce, as I'll talk about in a moment. This was the position in the morning. I added the arrow to show how the hurricane would be steered by this upper level flow, which was very, very strong. So that means that it would not just be steered straight toward New England, it would be coming very, very fast. And part of the analysis I've done for the book was that the three big ones in New England, 1815 and 1635 plus this one, all had the same characteristics of likely having had very strong steering and moving really, really fast, likely also transitioning into extratropical as they were making landfall. And I'll talk more about that. This analysis is for 10,000 feet. Back then, the analysis were in feet, and we didn't have analysis until that went too high because most of this was from plane observations, instrumented planes that would fly up and down to get some upper air information. Next, please. So also for the creation of the book and with the help of one of my students, we put together a composite of New England hurricanes. So these were from the NCEP-ENCA reanalysis of the conditions for the atmosphere, and that goes only back to 1948. What we had at that time was that. And we chose 7 storms, I believe, that were New England hurricanes. Most of them were much weaker. All of them were much weaker than the 38 hurricane, but the composite shows a trough, a deep trough, They also show a jet stream that has what's called a jet streak, that when you align a storm in the correct way, Dr. Uccellini is an expert in this, then you can transition from having energy of a tropical cyclone to the energy of an extratropical cyclone. You can get upper level divergence that allows the wind to go up and intensify. And also the surface had a very strong high pressure over the ocean, that same thing that Mitchell had identified as something that would not allow the storm to recurve. And this is not as deep as the one analyzed by Pierce in his analysis, but also these were not as strong hurricanes. But we were able to see how it was likely that storms that go straight into New England as hurricanes often have an upper air flow that is beneficial to at least slowing down their weakening. Okay, next, please. The upper air observations in 1938, I actually found an analysis of them. These are 10,000 feet, the same that the analysis is for, as I said, mostly airplanes. And most of the observations were in the middle of the country. The problem is that it was a lot easier to do in these areas. And weather balloons were starting to be used, but at first you had to go find them, the balloons, to get the observations. They had what they called, they built what they call a meteorograph. So you could only know the observations if you found the balloon afterwards. So then they started using radio. So at first they call it radio meteorograph. So they gave up on that name very quickly and started calling them radiosondes. But it was not until the year after the hurricane that there was a concerted effort to coordinate the weather balloon launches. And it was not until the 1950s, with the International Geophysical Year, that a worldwide network of upper air balloons were put in place. Next, please. So the storm was transitioning into an extratropical storm. So it was undergoing extratropical transition. And normally that's a good thing. Their extratropical cyclones are much weaker than hurricanes. Hurricane Noel there in the image is an example. You have that coma cloud that is a signature of extratropical cyclones. But I would like to argue that this timing was the worst case scenario. The storm was still strong enough to make landfall as a Category 3 with the strength of a Category 3 hurricane. The Saffir-Simpson scale did not exist until the 1970s. So this is going back and applying wind speed strength to it. And so it caused all the same effects that a major hurricane landfall would do with the storm surge and the wind damage. But since it was transitioning into an extratropical cyclone, it grew in size enormously. So the entire region, the track almost didn't matter, because the entire region, Long Island, southern New England, northern New England to Quebec, it was all encompassed by this storm. And there have been a lot of rain happening already, as Dr. Minsinger mentioned. By the way, this is a story for another time, but I suspect there might have been an atmospheric river thing going on, at least what we call a pre-existing rainfall event. But anyway, a lot of rain had happened already, and we have the observations from many stations to show that. So the ground was already wet. Many rivers and lakes were already near flood stage. So when this storm came, it just took it over the edge, and also it caused that huge forest and tree damage that we saw before. So super widespread devastation because it was so large. If it was just a major hurricane making landfall, it would not have covered the entire region like that. Next, please. So what Pierce did is that he got fascinated with the storm. He found all the data he could do. He put together this amazing paper, the meteorological history of the hurricane. He included more than 50 maps of surface and upper air analysis. The one on the right are morning and afternoon analysis, and he actually drew fronts. Doesn't have the front symbols we're used to, so he knew there were fronts. And in his description, he talks about the surprising matter of this storm, this hurricane, showing the signs of having transitioned into an extratropical cyclone. So what I wanted to do was say that Pierce discovered extratropical transition, but I had to back that a little bit because examining monthly weather review articles all the way to the 1800s, I found a note where typhoon experts in the Pacific were speculating that tropical cyclones, typhoons in their case, would transition into an extratropical storm. And they said that there was no way to observe that because we didn't have enough data. So we finally had enough data, and Pierce was the first one to notice this. So he at least deserves the credit for that. Also, this study is amazing compared to any other hurricane report and monthly weather review that usually talked about track, damages, and things like that. This was as modern a synoptic analysis of a storm as you might find much later, decades later. Next, please. So also speculation that Mitchell was fired and things like that. None of that happened. Mitchell continued. They both had long careers in the Weather Bureau, Weather Service then. They both won awards. And the week after the storm, the Department of Agriculture requested that the Weather Bureau explain themselves why they had not forecasted appropriately. So there was this very long letter, which is really a report. It's not signed, but I believe it was written by Mitchell. And there's no mention of somebody forecasting it correctly or anything like that, just speaking of how little data they had. So I did a trip to the National Archives, and I was fascinated. I came across this report that had been very obviously been just folded into a folder with a gigantic map for decades, likely, maybe even since the hurricane happened. So I was able to see also that report included every single advisory that was put together by the Weather Bureau, from Florida, the Florida office and the Washington, D.C. office. So I was able to build a blow by blow, all the advisories and try to interpret them and see the evolution and all that, which I included in chapters 4 and 5 of the book. Next, please. So a lot of the things that Dr. Minsinger mentioned, plus a lot more detail into what I just presented, is in the book. There was an update for the 80th anniversary that the AMS published. But funnily, what we had to take out in order to do that update, there's an extra chapter 10, was that report from the Weather Bureau, which I included as an appendix in the first edition. So if you ever come across a first edition, that report is included. But I also put it in the website for the book, that takenbystorm1938.com. And so you can find the full report in there. Also, I have an account in there. Back in 2017, Pierce's family contacted me because they had just learned about the book. And according to them, their father and grandfather was very humble. So he never really told them much about it. So according to them, everything they learned about that day was from my account. They also gave me that picture of him from the 1980s or so. So I wrote down a description of their visit, some wonderful stories that they told me about him, also available as supplements in the website. So next, I think this is all I have. Happy to answer questions, and happy to pass it to Dr. Louis Uccellini.
Thank you, Lourdes. And Bill, I'm delighted to be here this evening. And I can say that getting interested in this storm started early in my life. Growing up on Long Island, I heard about two storms from my parents. One was the 1947 snowstorm, which at the time produced a record-breaking snowfall on Long Island, Western Long Island, New York City, and this storm. And every time we drove over the Shinnecock Canal, doing something out east, my father would always say that, 38 hurricane created this. And this wasn't here before the 38. I heard all kinds of stories, and they were further west. We were in Nassau County, so we didn't get the brunt of that southerly flow. But, I heard about this storm, and I used Lourdes' book to spin up on it the first time I was asked to give a talk about it. So it's a great book. All right, next slide, please. So I do want to say I got one slide on the 35 storm because I think that does answer the one question that's in the question and answer about, what did Mitchell and the team there expect to happen, in terms of in their neck of the woods. I'll get to that in a minute. A few comments about the impact. The post, I do want to focus on the 38 storm, and I'll try to rush through this first part of the talk to be able to do that. Okay, next slide, please. So this is, just the one slide I have on this 35 storm, which was a killer storm for the Keys in southern Florida, and developed very rapidly as it moved into that area just southeast of the Keys. And the information I got about this book was from this Category 5 by Thomas Neal Knowles, which is another great book. And When Heavens Roared about Camille is the third. It was sort of a trifecta. So Lourdes' book got me reading about all these other storms, and it's inside what was going on during these storms. But they lost situational awareness of that storm, even as it was approaching the Keys. They didn't know exactly where it was. They didn't know it was a 5. This was the first landfalling storm was a 5. And they were sending troops down to the Keys to help clean up on this railroad line that existed. And that train got wiped out by the surge. They lost 251 veterans just in that train wreck. And you can see the damage. This had an enormous psychological effect on the forecasters, and then they report out on the nations. There was a fear embedded in these storms. All right, next slide, please. So when you look at the track of the 38 storm, coming in, there was a longer lead time once they knew there was a storm out there and people were tracking it. It was in the news. And quite frankly, the concern was, is it going to hit Florida? All right, because they're still reeling about the 35 storm. And then when they detected the turn to the north, there was this automatic assumption that turn would continue. And like when that Keys storm hit, came into the Gulf and then made that wide turn, there was an expectation that would carry on, that turn would continue into the Atlantic. They didn't anticipate the north would track. They did not predict the remarkable acceleration. And as we saw, it killed between 682 and 800 people. They really don't know exactly how many people it killed, but they give this estimate. All right, next. Now, when you look at this storm, and this is from one of Charles Pierce's analysis, it's really a remarkable analysis, by the way, shows that extratropical transition occurring with that inverted trough infernal zone. You can see the record wind speeds, the record storm surge, again, on that southern and eastern part of the storm coming into eastern Long Island and directed right up towards Rhode Island. Torrential heavy rains along that inverted trough. So just double down, even with the previous one, and then catastrophic inland flooding. All of these factors were not warned for. If you hit the next click, none of these were warned for. So for anybody living in this area, this was a big surprise. All the killing factors of this storm were a big surprise to the people affected. All right, next. The other thing about the post-storm maps is the acceleration. I thought I'd show this. The morning position, where they turned to the north, and the New York Times and other newspapers with their morning weather forecasts it was just going to go to the right. We dodged the bullet on this one, essentially. And even as that storm was hitting approaching Long Island, and they put out that warning for that northeast storm, that was done by radio. They were already being affected by this storm. So in a sense, the folks that were working the Great South Bay off of Long Island and points east had no clue this was coming. They actually saw the storm surge coming in at them. Okay, and actually Shinnecock Canal was created after that water receded out. It just found that weak spot and pulled everything back out through that area. All right, next. I had to show the jet, and the jet streak characteristic that Lourdes had in her book. Notice the entrance region where that storm was coming into. We see this with accelerating storms that are transitioning extratropical, and it also points to the area with the heaviest rain along that inverted trough. That upward vertical motion on the right entrance region of the jet is right over the area of the heaviest rain. So this type of system with a deeper trough, as Pierce analyzed it, was just loaded in terms of the transition to extratropical and the vertical motion needed for the heavy rainfall. All right, next. Now, how did people get the news? They got it 2 days later. This is the news that hit the theaters. Okay, can you hit that? Very dramatic.
September 1938. The eastern seaboard is lashed by a tropical hurricane. For 2 days, the coast from New Jersey to New England felt its full fury. New York was a city of deluge, as 70-mile-an-hour winds whipped torrential rains for hour after hour. It turned streets into rivers and slowed the pulse of the city. The hurricane center cut north across Long Island, and damage to suburban areas was staggering. Drains and sewer systems were useless, and the raging seas poured millions of tons of water far inland. Fire compounded the disastrous ravages of the hurricane. In London, Connecticut, for example, the waterfront was gutted. Blocked roads isolated the community. No help could reach the beleaguered firemen. As the storm spiraled out to sea, there was a sad inventory to take in the eastern states. From Atlantic City to Twin Mountain, New Hampshire, the hurricane had left a trail of devastation. $300 million was a conservative estimate of the damage. 600 people were dead, and the task of rebuilding taxed the resources of town and hamlet. Wrecked fishing craft and pleasure boats numbered in the thousands. Not one port along the Atlantic coast escaped the wrath of the hurricane. Against nature's fury, man had no defense. He could only flee to safety, leaving possessions behind. This Long Island train was tossed from the tracks like a toy. The hurricane of 1938 was the worst storm to hit the eastern coast in recorded history. But it ushered in a new era of scientific storm warnings. Probably no future storm will ever take such a toll.
So a pretty good forecast, actually, for the, except it took another 50 years. So let's go to the next slide. I like this slide, this before and after. This is from Keene, New Hampshire, and I showed this to Bill. He said it had to be at a high level to have that kind of damage with the trees that shredded. But it really shows the magnitude of the damage inland. It's not just along the coast. This is a remarkable destructive storm. And when I went to the Harvard Forest in north central Massachusetts, about 15 years ago, they made a decision not to clear that. Let's let nature. They actually are studying the how the forest recovers from a storm like this. I got to tell you, even about 15 years ago, it had a long way to go to get back into active tree growth. So this is, I think, one of the most remarkable pictures I've seen of this storm's fury. All right, next. So on the impacts, it stretched of coast to coastal communities and cities to well inland. The catastrophic destruction of buildings and infrastructure was widespread. Power lines, roads, and railroads. And this part of the infrastructure was amazingly destroyed. And you'll see what this led to. The complete surprise related to the hurricane's arrival compounded the impacts, and related lack of situational awareness increased the death toll. And in preparedness, there was zero preparedness. President Roosevelt actually used a fireside chat in October about the Great Hurricane. He called it the Great Hurricane Speech to mobilize the country through the Works Project Administration, seeking volunteers to accelerate the response and recovery to this national disaster. And when I was preparing for this talk in 2018, Charles Bell actually found this interesting clip from the WPA. They didn't pull any punches, let's put it that way.
Of all the signals of the sea, none turns the faces of hardy sailors more grim than the flags that spell hurricane warning. One morning late in September 1938, the dread signals swung aloft along the Florida coast. Up from the West Indies, cradle of hurricanes, moved the Terror, a pit of low atmospheric pressure into which the air rushed from all directions to form a whirling, shrieking vortex of high wind and heavy rain. Hurricane! The Coast Guard watched it warily as it moved northward, paralleling the coast. That night it was off the Carolinas. Next morning it was off Maryland and Delaware, apparently swinging harmlessly out into the Atlantic. But a high-pressure area at sea deflected the hurricane back toward land. September 21st in mid-afternoon, this tropical terror struck, swept over outer Long Island, swept into thickly settled, highly developed New England, struck with winds roaring 100, 150, almost 200 miles an hour. Tidal waves 30 to 40 feet high struck a section unprepared. In 3 days, an army of 110,000 WPA workers had been shifted to emergency storm and flood duty. Every little man with a pick on this map represents 1,000 workers of the WPA. Manpower turning from regular public improvements and services into the breach in time of dire need. Where tracks remained to carry trains, thousands of these workers came by rail. Shock troops of disaster, someone has called them, because so many times in recent years they have provided the human sinews for great tasks of reconstruction. The call may come from a great drought on the plains or a raging fire in the timberlands. Wherever there is trouble on a heroic scale, there you will find this peaceful army recruited from the ranks of the unemployed, working hard and well with the other agencies of mercy.
So the volunteers of the unemployed, 1938 was probably the worst year for the Depression. Probably wasn't hard to get these volunteers, but they had to get them up there. And it certainly made a difference. There were areas that took months to recover from this. And one of the things about the rail infrastructure being wiped out in certain areas between New York City and Boston was that a lot more people started flying in airplanes. And this is actually cited as one of the reasons people started flying. They lost their hesitancy about getting on an airplane because they had to get up, for whatever reason. So anyway, it was kind of interesting to see how they mobilized the unemployed to get into this area and work months, if not years, on some of the inland areas to recover. Okay, next. So this reaction to the 1938 hurricane provided a foundation for the modern forecast process. That's one thing I want to convince you of with this. It's the beginning of the Reichelderfer area. The previous director had died of a heart attack actually in Chicago the week before this storm. So as part of the review of the forecast for the storm, and the 1935 storm was sort of thrown into that too because of what happened in the Keys. They went to an outsider who is Francis Reichelderfer. He was in the office of what I think now would be the Office of Naval Research. I don't know what was called that at the time. The first thing he was recommended by Rossby. Rossby was very influential in this country at that time, and strong recommendations to hire Francis Reichelderfer. This accelerated the first thing he did was accelerate the transition to the air mass front concepts as a basis for analysis and forecasting. There had been, like we seen here, experiments with this. He was in the process of establishing the radiosonde network in the eastern and midwestern United States, principally for commercial air traffic. The growth of air traffic was really the driver for this radiosonde network. By 1941, that actually led to the move of the Weather Bureau from the Department of Agriculture to the Department of Commerce, as air traffic was looked to as this big driver for the commercial airspace. World War II interrupted that, but post-World War II, he set about introducing the radiosonde network, not only in the United States, but around the globe. He was the first president elected for the WMO. All right, so he carried that with him. The radar network post World War II, with Harry Wexler, at his right hand, noted scientist. They went right after that radar network for severe storm. Started introducing watch warnings out of Kansas City in 52, 53, 54 timeframe. Okay, operational numerical modeling. The U.S., Sweden, and Great Britain were the first countries to introduce real-time operational forecasts. The thing about the United States is when they started it, they never stopped. Okay, they just, it had problems. They kept on going forward with it. He was very aggressive when Charney and the folks up in Princeton were working with von Neumann's computer, and finally 2 years later, we're able to show a cyclone prediction for that great November storm from 1950. Very aggressive to get that into real time, okay, and then operations. So 1954, the joint unit was formed. By 1959 or 60, NMC was formed. All the time, they're working to improve numerical modeling. And then he embraced the satellite imagery in the early 60s. He retired in 63. He didn't wait around. He got the recommendations. You got to get this stuff into the forecast office. So by the time they got and Sumi was a big part of this out in Wisconsin. By the time they got the geostationary satellite up, he all in. However you can get that information to the forecasters, they were already working that by the early 60s. So when I go to the first type of observing system that really revolutionized the ability to sustain the situational awareness, if we go to the next slide, it's by far accepted that the geostationary satellite was that instrument. This is Robert Sheets' review article on the National Hurricane Center that he wrote in 1990. And this was the sentence he wrote in that article. If there was a choice of only one observing tool for use in meeting the responsibilities of the NHC, the author would clearly choose the geosynchronous satellite. All right, so that whole process started with Reichelderfer's team embracing satellites from day one and moving it into the forecast offices as soon as they could. Right, next. The other aspect is numerical modeling. He embraced that, day one also. So now we have a modeling system involved with, global observations, data assimilation, and modeling science. There's an increasing emphasis on multi-model ensembles, as we'll see in the next slide. Supercomputers, the new one that's just been spun up at NCEP is 14.4 petaflops per system. An incredible speed now. And then, of course, the forecaster skill, and there is a forecaster skill involved in this, not only in making the forecast now, but connecting with decision makers out in advance with the increasing uncertainty to alert them to the possibilities and continually working with them to refine the forecast as the system comes closer and closer. So that's our forecast process today. And I'm not exaggerating when I say a lot of this has its basis, has its roots in what happened in post-World War II and the 1950s in Michael Durfer's domain space. All right, next. This is a sweep of the seamless suite of forecast products that were there. I know it's being changed, and it's been 2 years now. But what I wanted to show with this is the increasing emphasis on multi-model ensembles across all scales. So from mesoscale, which we were pioneering, the European Center was pioneering ensemble forecasts from medium range on up. We've combined all of this all the way out to subseasonal and seasonal. These models are run every day. And this is what it's meant by the seamless suite. So we see today this ensemble approach, which gives us this area of likely movement of storms, development of storms. And this is what allows the weather service, the private sector, the weather enterprise to work more effectively for conveying the uncertainty associated with forecasts longer out in time now, which is where you need to start preparing for these storms. The emergency management community doesn't start preparing 2 days before landfall. They're working with these possibilities 5, 6, 7, 8 days in advance. And I can tell you that with Lee, I'm sure the emergency management community was working with the whole weather enterprise, preparing for that landfall in New England towards southeastern Maine, 8 days before the event. So this is an important part of the forecast process now. Okay, next. So can these storms happen again? Click. Yes. And one, in terms of uncertainty, taking a path that's kind of not expected to occur because it really hasn't happened before, was Sandy. Okay, so if you can hit right to the left of they, yeah, there you go. So this is a 5-day, about a 6 or 7 day loop actually, of Sandy, intensified, and then went out and came back into New Jersey. And that turn back to the east was the source of a lot of forecast uncertainty. I can tell you when we get to the forecast of this, that was a forecast that was actually done 5 days out. The forecasters were using a combination of the European Center model, which had the storm moving more up along the coast, and the GFS, which had it going swinging wide right, with catching another jet stream to do so, and then bent it back in. So it was really the first forecast to catch the turn to the west. And this was really important because that acceleration with that storm and that east to west movement really amplified the surge in New York Harbor and northern New Jersey. Okay, next. So if you look at the forecast from starting about a week in advance, they're tracking this storm. You see there's that turn to the left about 5 days in advance. And we're tracking this and sustaining it and accelerating, refining the forecast, reducing the cone of uncertainty as the storm approaches. So was it a perfect forecast? No. Did it catch people by surprise? I don't think so. In fact, I know that the emergency management community from the federal down to the local level were plugged in to that forecast uncertainty early on and working with us, and people have their private sector forecasters to really nail down where this was going to be. By the way, that big snow event, the blizzard in Western Maryland and in West Virginia, first time ever that a Hurricane Center bulletin had a storm surge warning and a blizzard warning in the same. That was forecasted 3 days in advance. And the people in West Virginia and Western Maryland were ready for it. So it was really a tremendous forecast. from a lot of angles. All right, next. The other aspect of this is that before 2013-14, when we actually institutionalized the use of impact-based decision support services, where you're working with emergency managers at every government level, well before a storm. You train with them, you get them to trust you in terms of the way you're working with the uncertainty early in the storms and these models going in, so that there's this incredible relationship now and partnership amongst emergency management, public safety officials, not just with the Weather Service, but with the entire weather enterprise. Many of the folks in the private sector or Weather Ready Nation ambassadors they're plugged into this. And this is so important that we updated the NWS mission statement in 2021 to include impact-based assistance support services in the Weather Service mission statement to connect the front part of that mission statement to actually saving lives and property. You need this extra step of reaching out. And I'll just give you one example of how this worked for Irma in 2017. If we go to the next slide. Up in the top corner, you see this forecast of Irma, and then the actual, that's the forecast, making that right-hand turn. Okay, now, the actual storm was closer to the coast of Cuba, so Cuba actually got worse damage than was expected this far out. But that right-hand turn was incredibly important because it meant that the whole state of Florida was going to be affected. They might have to evacuate people along the whole track. So with this storm, there was actually a state of emergency 6 days before landfall that was issued by the governor of Florida, because they had to evacuate people from the Keys just to get them out of the way, depending on whether this storm was going to go to the west, up the west coast, or up the east coast. They didn't want all the traffic from the Keys interfering with their evacuation. This was a gutsy, not only gutsy forecast, but a gutsy decision on the part of the government of Florida, especially because they really had, in a sense, they had no choice. They had to start 6 days before this storm was approaching. So this was sort of a measure of success, and I can tell you, since 2017, there's still all kinds of challenges. You know, the Harvey, amplifying from a 2 to a 4 as it's making landfall. Some recent examples on the west coast of Florida doing the same thing. These rapid intensifications, even as the storms were approaching landfall, is still a major research issue. But you've got not only the scientists, the researchers and universities and laboratories, but the forecasters and the users of that forecast working together to deal with problems like this. So if you put on the next slide, please, I think it's my summary. I'll just say that between these two storms, they had an enormous impact on the history of the Weather Bureau, and a number of steps were added. And the other point I like to make, it's not a light switch when you're making these kind of changes. It takes time. You introduce, you test, you train, you move forward. This, like other parts of the Weather Service history, I'll just late 1800s, the two blizzards of 1888 is what created the Weather Bureau out of the Signal Corps and moved it into a civilian organization. And between 1888 and World War I, there were a number of efforts to move those forecast offices onto university campuses. The R2O process was in full swing. So this is an interesting part of the history, and the 1938 storm fits right into that storyline. So thank you very much, and I'll turn it back to you.
All right. Well, again, here's a thank you to all those attended, and I want to thank Dr. Uccellini and Dr. Avilés for sure for participating. And I think we have one question. There was a question with regards to Napatri Point. So they were talking about, again, the coastline with regards to preventing rebuilding, perhaps, where there had been significant damage. And Lou, do you know whether other states have done that, where there have been areas that have been so hard hit that they changed the zoning so that people couldn't rebuild?
You know, I really don't know the exact nature of those local decisions post hurricanes, whether it involved zoning or not. But I think one of the more famous cases is the Galveston seawall that was built after the famous hurricane down there that killed thousands. It's considered the worst natural disaster in the United States, killed over 6,000 people. So there have been efforts to either build seawalls to mitigate impact, or I don't know if there's a restricted building aspect anywhere. I just really can't answer to that.
So
I would assume that there were some, but I just don't know of any particular one.
That, as you said, that's very local zoning and local regulations. A few years ago, I saw some wonderful talks at the Southern New England Weather Conference that dealt with these topics, but I can't remember the details. But you have to figure out is that these are very, very high priced areas, right, where people have their mansions so that they can have their beach houses. So I imagine there would be, a lot of local politics trying to avoid or trying to go forward. I would imagine it would turn complicated. By the way, there were other questions. I've been answering them directly in the Q&A. So I don't know if either of you want to attack any of those.
I just seen this one from Nick about the warming world. I've been I haven't done any research on this. I've read research which points to perhaps fewer storms, but more intense storms that actually occur. Still, being tested out. With respect to how these things move and track, I think one of the interesting things we're seeing is the changes in what's going on in the Arctic, and what that's doing in terms of cross-polar flow, cutoff lows, more blocked flow regimes, which clearly are going to have an impact on the extratropical tropical interface. Exactly what it means for individual storms, I don't know. I can see situations where you might be pulling these storms up further north faster, not slower, just based on how these phasing of troughs occur. But I think that's, people are actually doing research with higher resolution climate models now that are fully coupled with ocean, land, atmospheric coupling, and better representation of the cryosphere. And I would stay tuned to what comes out of those studies, because those types of higher resolution models, especially with more information in the Arctic, I think are going to show some really interesting things with respect to the Arctic extratropical, tropical interactions that will likely surprise us all, which is what research tends to do.
One thing to take into account as well, let's say that the storms themselves didn't change much, which is not unlikely, with the higher ocean levels. The storm surge and the waves and all that would affect further inland than the areas that are accustomed to these types of storms.
Yeah. One of the things I saw last week at a meeting I went to at the Americus up in Baltimore, in these coastal domains with these regularly occurring tidal flooding, the intrusion of the salt water into areas that haven't experienced it before, causing lots of damage to infrastructure and other natural areas that, again, are not used to having salt water lapping at the roots of trees and things like that. So you put a storm surge on top of that, and I think you're going to see a world of hurt further inland, as you noted. And what with these surge models now, they're actually tracking, surge predictions up these river basins. They can go 20 miles, 20, 30 miles upriver, and they're verifying with these storms that are coming into the Carolinas, for example, over the last 5 years. So, it's a lot to learn here, as well as just, make sure that we make this part of the forecast process, because that brings the damaging effects of these storms further inland.
I always like to remind people as well that inland flooding, we have a lot more paved surface and a lot more developed surface than there used to be, especially in northern New England now, so that all of that runoff can more quickly enter streams. So that has to be factored in some as well. That we've sort of created a little bit of our own worst scenarios, in the sense that, now just a few inches of rain sometimes can cause flooding if it occurs quickly, because everything runs in from hard surfaces.
And if I like to speculate, prompted by one of the questions, made me think about this. So if this happened today, exactly the same storm, I would like to think that our forecast was good enough that we would know way ahead of time. We would see it coming. Hopefully the local areas would get their evacuations in place. But we have more trees than back then. We have more infrastructure. We have more buildings on the coast, and not fishing shacks, like a lot of them were back then, a lot of big, expensive buildings. So it would be interesting to see what exactly the same storm, not even considering climate change, exactly the same storm, what kind of damage it would do and how we would recover from it in current practices and, forecasting abilities.
Yeah, I think people will be shocked, and we sort of alluded to this 150-year cycle. So sometime within the next 65 years, a similar storm might occur, and I think people would be shocked at the amount of damage. Even that, with the amount of pleasure craft that are susceptible. Still people having their boats in the water in September, October. That's another. You can't pull all those pleasure craft out in a day or two, and that occurred in Hurricane Bob. There's a tremendous amount of damage to pleasure craft.
Yeah, Bob was another example of an accelerating storm. Right. I remember very clearly when the Hurricane Center was updating the forecast at noon for Bob reaching southeast New England. They had a forecast for landfall at about 5 o'clock in the evening or something like that. A forecast that, and over that 2 hours, I think, while the forecast was being made and discussed and everything else, that storm just accelerated. It was already making landfall right after 12. I mean, it was just an amazing acceleration with that. So,
and Bob is one of those storms that were used for that composite.
Yeah.
And so was Gloria and Carol.
So that turn to the north, when it stays and it accelerates out, has always been a very, very difficult forecast challenge, not only in terms of the magnitude of the turn, but the acceleration of the storm itself. It's
and that probably is true with Lee that just occurred, because I think that sped up a little faster than what they were originally forecasting with the computer models.
Yeah, but the models were doing that at day 8.
Well, that's true. Yeah.
Yeah, you got to give a little. I mean, the models were actually showing, a whole host of models were showing a westward shift of the track up until about 8 days in advance, and then it started oscillating in that area between Maine and Nova Scotia. And I thought it was just remarkable, actually. But yeah, it also it was accelerating in those runs too, but not to the extent that happened in real time.
Mm-hmm.
Any other? Did we cover all the questions?
Yeah. By the way, on Lee, what was really remarkable was that on NPR the following morning, people were talking about we were ready, and they had people pre-prepared to clear roads and cut trees and respond to wires down and all that. And they had everything open in 12 hours, because they were ready. They were pre-positioned. And you're seeing this in the severe weather arena too. First responders converging on towns that just got hit by the tornado because they're pre-positioned. They're all mobilized, and then they're watching the radars with everybody else. And then coming in right on the back end. That preparedness and getting things ready days in advance is absolutely critical for that saving lives and property aspect. It's just incredible.
And one thought, several years ago, I had the chance to go to a New Hampshire emergency preparedness conference, and I was surprised to hear the 1938 hurricane still being talked about as the worst case scenario that they needed to prepare for. Different aspects, dams, different areas of emergency management, and 38 hurricane still used as, if we're ready for what happened in 38, maybe we're ready for when it happens again.
And for people in Western Virginia, east side of the mountains, bring up Camille, and think about those rainfall rates over a rural area a lot longer than what happened over New York City with Ida. But it was the same kind of dynamic, same kind of interactions between a remnant and the upper level jets and stuff. But how do you forecast to get people ready for something they've never seen before? Okay, and I think that's the problem they would have had in 1938. People just hadn't seen that stuff before. So, big challenge. Well, again, thank you, Lourdes and Louis, and I hope people enjoyed the talk. And again, keep in mind that it can happen in New England, and it did happen, and probably will happen again sometime. And hopefully, again, we will be better prepared for it. Anything else to say? Nope. Just thanks for having us, Bill.
Yeah, thank you for having us.
Very good. Well, again, Gideon, I think we're probably set.
All righty.
I hope we have covered the questions and kept people from falling asleep. We'll see whether anyone leaves here. Maybe everyone's asleep on the other end. No one will leave the conference. All right, Gideon.
Well,
thank you.
So much.
Thank you for setting this up as well through the AMS. We appreciated the opportunity to present.
Of course, yes. Thank you, doctors, for sharing your knowledge, your insights, your experiences.